Hello guys, welcome to this lecture. In this lecture we would be talking about Kubernetes. So Kubernetes basically means it's a Greek word for helmsman or pilot. It schedules, runs and manages containers on a cluster of virtual or physical machine. It has declarative approach, try permanently to reach the declared cluster states. It was started by Google in 2014 based on over 10 years of experience. Borg. Its first release was in July 2015. It was donated to Cloud Native Computing Foundation. It's 100% open source and it's Go. So let's start one by one and discuss on the few features we find in Kubernetes. First of all, pods. So pods are nothing but they are smallest deployable unit. It's small group of tightly coupled containers. Its shared network and data volumes. Its routable IP address and model. Second is replica sets. It runs and copies replicas of pod. It starts or kills pods if necessary. It handles pods failures and it does health check as needed. Deployments. It contains declaration of your application, which container, image, tag, etc. Environmental variables, data volumes. It defines number of replicas. It creates replica sets, which in turn create pods. Next is services. Pods are mortal. Services provide a permanent virtual IP and DNS name. Proxy traffic to selected pods, simple load balancing including session affinity. Next feature is ingress. It exposes services to the outside world. It maps URL to the services. It does SSL termination. It needs ingress provider. Namespaces. Namespaces group Kubernetes resources which are pods, replica sets, deployments. By default, everything is in the default namespace. Creates namespaces for your environments, example test, staging, production, or tenants. It restricts access to specific namespaces for K8 users. Namespaces can have separated network depend on network provider. Cluster. A cluster is a set of virtual or physical machines running a K8 master and one or more K8 worker nodes. Cluster federation. It runs a federation master which knows all your clusters. Run your apps distributed across clusters, example across Amazon, Google, etc. regions. Secret and config maps. It separate your application code which is equal to images and configuration. Both secret and config maps are key value pairs. It uses secrets for binary values, example certificate keys, etc. It uses config maps for string values. Both can be read by the container via environmental variables or mapped into a data volume, example like property files. Next feature is data volumes. It maps directories into containers. Multiple containers in one pod share the same volume. Many volume types like empty directory, host directory, Google persistent disk, Amazon blobs, store, NFS, cluster RFS, RDB, CEFs, JIT repository, etc. It can be pre-configured by cluster admins for easier usage by cluster users. Pet sets. A pet is a stateful pod. A pet set has a scalable number of pets. A pet is bound to a dynamically created data volume. That data volume will never be deleted automatically. The pet is bound to the same volume on a restart. Next feature is jobs. Sometimes you need to run short living tasks. A job ensures that a container which executes such a task runs successfully exactly once or more times. Retry on failure. Scheduled jobs can be started at specific times like cron. Daemon sets. The daemon sets run pods on all or selected set of nodes in the cluster, useful for running containers for logging and monitoring. Autoscaling. Horizontal pod autoscaling scales replica sets based on pods, CPU usage, or app provided metrics. Cluster autoscaling scale the number of nodes in your cluster based on CPU and memory usage. Depends on cloud provider. API. Every functionality is provided via REST API. Easy integration in your existing workflows, continuous delivery, command line tool like kubectl uses the REST API internally. And finally, the community. It is a constant growing community active on Stack Overflow, Google Groups, and Slacks. Many contributors from many companies, and of course, there is a KubeCon conference. So that's it for this lecture. In the next lecture, we would be discussing a few related theory as well. And then we will start with couple of practical stuff. Thank you very much.